So good morning. So today's class we are going to see about power transmission systems. Okay. So in power transmission systems, we'll have a rotary to rotary motion, rotary to linear motion, gear systems, belt drives, and harmonic drives. So whereas in the case of in power transmission systems, so they are used to transmit motion from the prime mover to the end equipment, and that is we'll have a motion conversion, that is a rotary to linear, linear to rotary. Okay. And whereas in the case of power transmissions, so they are widely used in robotics, particularly in gears, belts, chains, and shafts. Okay. So this we can see in detail one. So the what are the power transmission elements அப்படின்னு பார்த்தீங்க அப்படின்னா, we'll have a driving and driven shaft. We'll have a connectors for transmission of motion and power from driving to driven shaft. That is, we'll have a belts, chains, gears, ropes, and pulleys. And whereas they have supporting elements, we'll have a axle, bearing, bracket, and the holding elements வந்து பார்த்தீங்கன்னா, we'll have a coupling, pin, key bolts, and nuts. Okay, so these are all the elements which is used for the power transmission. So let me see one by one. The first thing we are going to see about the rotary to rotary motion conversion. So whereas in the case of an input rotary motion, they will be converted to output rotary motions, but with different speed and tackle levels. So the widely used conversion systems pathina will be using gear trains and harmonic drives. Okay. So whereas the input rotary motions on the pathina, it will be converted to output rotary, but we'll have a different speed and torque levels. So gear train, it is a series of gears will be connected so far. So where the gear turns will be proportionally when driven by a prime mover. Whereas the output speed and torque வந்து பாத்தீங்கன்னா, it can be increased or decreased using gear trains. So whereas setup gear train வந்து என்ன பண்ணும்னா, it will increases the output speed and reduces the torque. Similarly, reduction gear train வந்து பாத்தீங்க அப்படின்னா, it will reduces the output speed and increases the torque. Okay. So this is the thing. So whereas setup gear வந்து increase பண்ணும் speed, torque reduce பண்ணும். Whereas reduction gear வந்து பாத்தீங்க அப்படின்னா, will be reducing the output speed and increases the torque. So widely used types of gear trains வந்து பாத்தீங்கன்னா, we'll have a simple gear train and compound gear train. So simple gear train la what we'll be doing now, we'll have a series of gear wheels, so which will be mounted on the shafts between the driving and driven shaft. So ஒவ்வொரு ஷாஃப்ட்டும் பாத்தீங்க அப்படின்னா, it will be carrying one gear. So for example, இப்போ ஏங்கிறது driving gear, Dங்கிறது driven gear, B and Cங்கிறது intermediate. ஓகேவா? ஸோ இது வந்து ஒரு செட் ஆஃப் driving, driven, intermediate. So intermediate gears வந்து பாத்தீங்க அப்படின்னா, it will not affect the velocity ratio of the driving and driving. அதே சமயத்துல the intermediate gears என்ன பண்ணும்னா, it will change the direction of the rotation of the driven gear. So அதனால it is also known as to be an idler gear. Okay. So அப்ப number of intermediate gears வந்து ஈவனா இருந்தது அப்படின்னா, so driven gear என்ன பண்ணும்னா, it will rotate the opposite direction of the driving gear. So this is the concept which is begin the simple gear train. So so the intermediate gear வந்து it will not affect the velocity ratio and it will change the direction of the rotation. So, for example, we'll have the n for the notations, we'll have a number of teeth and the number of RPMs. We'll have a n notations and t notations for the A, B, C, and D. So, velocity ratio on the pathing we can define with respect to that is the driving by driven. Okay, A the driving and B D to the driver. So, RPM. So, we'll have velocity ratio of the drive. So, NA by ND calculate பண்ணும்போது பாத்தீங்க அப்படின்னா, we'll be having a TD into VR by TA. So velocity ratio between A and B. A and B பண்ணும்போது நீங்க என்ன பண்ணுவீங்க? So B by A வரும் உங்களுக்கு. அதே மாதிரி B and C வரும்போது C by B வரும். C and D வரும்போது D by C வரும். So between the driving and driven gears நீங்க calculate பண்ணும்போது, so we'll have the final expressions. எப்படி NA by NDங்கிறது TD by TA வந்திருக்கு அப்படிங்கறத பாத்தீங்கன்னா, NA by NB into NB by NC into NC by ND. So இது ரெண்டும் cancel ஆயிடும். So we'll have NA by ND. அதே மாதிரி அந்த சைடு பாத்தீங்கன்னா TB by DA, TC by TB, DD by DC. So everything will be getting cancelled. We'll have the final expression TD by TA. So whereas in the case of a compound gear trains the center distance between the two shafts will be very small and will be requiring high velocity ratio. So simple gear train practically impossible. Okay. So under cases we'll be using about a compound gear train. So in the case of compound gear train, the intermediate shafts will be carries two gear which are rigidly mounted on the shaft. So for example, A is the driving, D is the driven, B and C to be the intermediate. So in the gear B and C, they are to be named as an compound gears. They are be mounted on the same shafts and they'll be rotating on the same speed. Okay. So the velocity ratio, what I have shown over here. So the relationship between B and C வந்து பாத்தீங்க அப்படின்னா this is the ratio. So simple gears B and C same shaft இருக்கிறதுனால will be rotating at the same speed. So RPM same இருக்கும், but teeth will not be the same. So அதே மாதிரி இப்போ இந்த velocity ratio between A and D calculate பண்ணும்போது we'll have NA by ND is equal to NA by NC into NC by ND. So அப்போ NA by ND வரும் உங்களுக்கு. அதே மாதிரி அந்த சைட் பார்த்தோம் அப்படின்னா we'll have a Q over there. So அப்போ NA by velocity ratio பண்ணும்போது with respect to A, B, C, D நாலுமே இருக்கும் with respect to B and D and A and C over on it. So we'll have a reversed gear train, epicyclic gear train and power transmitted by gearing. Reversed gear train வந்து பாத்தீங்க அப்படின்னா, so in this gear train வந்து we'll have a first and last gears will be on the same axis. So back gear arrangement வந்து பாத்தீங்கன்னா it will be the reversed gear train which is used to reduce spindle speeds. Whereas the case of an epicyclic வந்து பாத்தீங்க அப்படின்னா, so simple and compound gear trainsல வந்து gear wheels rotates about a fixed axis. So while an epicyclic gear train வந்து axis of rotation of the wheels வந்து are not fixed at all. So they are used in motor cars and other vehicles. Whereas the case of an power transmitter by gearing வந்து பாத்தீங்க அப்படின்னா, if the losses due to frictions are neglected, then power output at driven shaft equal to the power input at the driving shaft. The next drive we have to see about a harmonic drive. So it is a mechanical speed changing device invented in the 1950s. So it operates on the principal arms over on it. Okay. So and they have the capabilities beyond the scope of conventional speed changes. So it consists of a thin ring which deflects elastically as it rolls on the inside of a slightly larger rigid circular ring. So whereas the case of a circular spine வந்து பாத்தீங்க அப்படின்னா it has the internal teeth that which with the mesh with the external teeth on the flex spline. So flex spline வந்து it has a fewer teeth and they'll have a smaller effective diameter than the circular spline. So the wave generator பாத்தீங்க அப்படின்னா it is a link with two rollers which rotates with the flex spline causing it to the mesh with the circular spline progressively. So if the wave generator வந்து rotates clockwise and the circular spline is fixed, the flex spline will rotate or roll around the on the side inside of the circular spline at a much slower rate in a counterclockwise direction. So the ratio of the input speed to the output speed வந்து பாத்தீங்க அப்படின்னா depends on the difference in the number of teeth in the circular spline and the flex spline. So speed ratio வந்து as high as 320 to 1 which can be produced in a single direction. So whereas the harmonic drives வந்து பாத்தீங்க அப்படின்னா வந்து they are to be lighter, smaller and more efficient than conventional high ratio drives. So strain wave gearing அப்படிங்கிறது it is a special type of mechanical gear system. So in the theory வந்து பாத்தீங்க அப்படின்னா it is based on elastic dynamics and it will be utilizes the flexibility of metals. So three basic components இருக்கு. ஒன்னு வந்து wave generator, flex spline and circular spline. So இங்க வந்து பாத்தீங்கன்னா wave generator வந்து input, flex spline வந்து output and we'll have a circular spline. Okay. So wave generator is made up of two separate parts, elliptical disc which is called wave generator plug, outer ball bearing. So in the figure I have shown the circular spline, flexible spline, wave generator. Okay. So for strain wave gearing mechanism, the gearing reduction ratio which will be calculated by using the formula. Reduction ratio is equal to flex spline teeth minus circular spline teeth divided by flex spline teeth. So if there are 202 teeth in the circular spline, we'll have a 200 on the flex spline. Reduction ratio on the minus 0.01. That 1 by 100th speed of the wave generator plug. At the same time, which will be running in the opposite direction. So next motion on the rotary to linear motion conversion. The input rotary motions will be converted into output linear motions and they will be used with the prime movers in order to operate the linear joints. So we'll have a widely used conversion systems, lead screw mechanisms, rack and pinion mechanisms, belts and chain mechanism, slider crack mechanism, tram and follower mechanisms. So over chain so single crank chain it is a modification of basic 4-bar chain. So one sliding pair will have a 3 turning pairs. And similarly, it will be found in reciprocating steam engine mechanism. So this will be converting rotary into reciprocal motion and vice versa. So whereas links வந்து பாத்தீங்கன்னா frame and cylinder, crank, connecting rod, crosshead or piston. Cam and follower. Cam and follower அப்படிங்கிறது cam வந்து பாத்தீங்கன்னா காமிச்சிருக்கேன் பாருங்க. It is a rotating machine element, so which gives a reciprocating or oscillating motion with the help of another element பேர் தான் என்ன அப்படின்னு பாத்தீங்கன்னா follower. In the cam and follower வந்து பாத்தீங்கன்னா will have a line contact and they'll have a constitute a higher pair and they'll be usually rotating at a uniform speed, but the follower motion is predetermined, so it will be according to the shape of the cam. Where we'll be widely using the cam operating the inlet and exhaust valves of internal combustions, automatic attachment of machineries, paper cutting machines, textile machineries, feed mechanism of automatic clocks. So இதுல எல்லாமே நம்ம என்ன யூஸ் பண்றோம் அப்படின்னா இந்த cam and follower தான் யூஸ் பண்றோம். camங்கிறது ஒரு rotating machine elements. Okay. So classifications of followers பாத்தீங்க அப்படின்னா according to the surface in contact வந்து will have a knife edge follower. So the contacting end of the follower வந்து will have a knife edge. அதனால தான் அது பேர் knife edge follower னு சொல்றோம். So purely the follower and the com வந்து பாத்தீங்கன்னா it is full of a sliding motion. So this is not used in practice because due to high rate of rear its edge. So it gives rise to considerable side thrust between the follower and the gate. Next follower வந்து பாத்தீங்கன்னா roller follower. So இங்க contracting end of the follower வந்து it's like a roller. Okay. That is a rolling motion takes place between the contacting surfaces. In roller followers வந்து பாத்தீங்க அப்படின்னா there will be a side thrust exists between the follower and the gate. So they are extensively used where more space is available in stationary gas and oil engines and aircraft engines. Flat phase or mushroom follower வந்து பாத்தீங்கன்னா when the contacting end of the follower வந்து perfectly flat phase இருப்பாங்க, it may be noted that the side thrust between the follower and the gate is much reduced in case of a flat phase followers. The relative motion between these surfaces வந்து largely of sliding nature, but wear may be reduced by offsetting the axis of the follower. Flat phase followers எங்க யூஸ் பண்ணுவோம் அப்படின்னு பாத்தீங்கன்னா where space is limited is used in firms which operate the walls of automobile engine. So circular இருக்கிறதுனால it is also called as a mushroom follower. Spherical phased follower பாத்தீங்க அப்படின்னா it is of spherical shape. So where the flat phase follower வந்து used in automobile engines. In order to minimize these stresses, flat end of the follower வந்து it is machined to a spherical shape. Next, classification of cam. So cam வந்து according to the motion and displacement of the follower with respect to the axis of rotation will have a radial or disc arm, will have a cylindrical arm. So radial camல வந்து the follower reciprocates or oscillates in a direction perpendicular to the cam axis. Whereas in the case of a cylindrical cams, the follower reciprocates or oscillates in a direction parallel to the cam axis. Okay. Next வந்து we'll have a lead and ball screws. So lead and ball screws that we can see in the next class. Thank you.